Welcome to Nano Zorro, the podcast of Tech Zorro, presented by Juditova. Engage with your ears about engineering, development and inventions, as well as interviews with experts and hobbyists. You will learn to make better decisions with your designs, programs and manufacturers in order to optimize and develop your products and services, or just for fun. You can find the show notes from the episode, the transcription, and much more by entering to techzorro.com/podcast. And now your host, engineer, crafter, and tech enthusiast, Juditova.
If you like this podcast or the blog, and you do want to support the show, go to our site in Patreon to contribute with a monthly donation. You will have early access to its episodes, you will be recognized as a Patreon in the website, among other benefits. There are several tiers available, starting from $3, or if you feel altruist or generous, there are superior tiers. You just have to go to the website techzorro.com/Patreon. In the show notes or description, you will find the link. We will kindly appreciate all contribution. All right then, let's start with today's episode. Welcome to a new episode of Nano Zorro. In this episode, number 5, we are going to talk about 7 types of electric motors that you should know about. In recent years, electric motors have gained more popularity with all their advantages, more silent operation, and they can operate in closed rooms. They later require less maintenance. And, with the new, let's say, revolution of batteries, it is more interesting than ever before to use electric motor to multiple, let's say, instances. But there is certainly not just one type of electric motor. Each of them, as we're going to see, have their own advantages, their weaknesses, their area of fields of appliances, and for many reasons you should know the criteria when each of them should be used. So let's jump into it. An electric motor is capable of transforming electric current into mechanical movement. They are used everywhere, from home to industries and factories. Some electric motors are preferred in certain areas than others for multiple factors. Every one of them has multiple considerations: a voltage input specification, electrical and mechanical losses, power consumption, and torque and speed output, among other factors, of course. This episode refers to the most important and used electric motors available in the market and some of their key differences. Furthermore, electric motors have an interesting feature. Some of the energy given can be restored back to the grid or battery as if it were being stopped. This is called regenerative braking, and I will leave a link in the description or in the notes of this episode so you can check it out. Types of electric motors. The most important criteria for classification of electric motors are the input source of energy. Thus, motors can be classified, are classified in 2 big groups: alternating current motors and direct current motors. Let's get inside the first one. All motors that uses electricity from the power grid uses AC current and depends on a alternating voltage input. It can be considered as alternating current motor. Most of these motors can be plugged directly into a power outlet and work out of the box. Some of them have efficiencies above 85%, which makes them very attractive for applications that consumes lots of power. All of them presents more difficulty to control the speed and torque output than the direct current counterparts. It is possible, no doubt, but it is not a straightforward solution in most applications. In recent years, however, the use of semiconductors have shifted into a simpler control of AC machines with the help of devices called variable frequency drives. Okay, so on the other hand, direct current motors uses, DC current. Since all power outlets transfer AC current, a converter must transform the alternating current into a suitable direct current first. DC motors are generally less efficient and require more maintenance. Some of them need a controller to work. DC motors are easier to control because of the simpler operation. Thus, they are more versatile. If speed variation is demanded for an application, DC motors are usually the way to go. Some have configurable windings, for example, series, parallel, compound, etc., that can be changed in response to a better torque speed performance dictated by the application itself. There is one kind that stands out of the rest of the DC motors, which is the Brushless DC Motor, or BLDC for short. They usually have efficiencies above 90%. They are easy to control and have low maintenance or even none. More on that later. Popular electric motors. So, which are exactly these mysterious 7 kinds or 7 types of electric motors that you should know? Okay, let's find out. Induction. In these motors, the AC current is delivered by the stator directly and it is passed into the rotor by the transformation act. The number of poles in the stator, which is the number of norths and souths, literally, determines the rotation speed of the rotor. In the market, you will usually find 2 types. Wound type, which is less common and less used, or let's say, used only in specialized circumstances. And squirrel cage, which offers built simplicity and robustness. Well, inside our induction motors, we have 2 subtypes depending on the input connection. Single-phase induction motor. They use 2 wires, usually phase and neutral, and they are popular in domestic applications where 3-phase connections are unavailable. To start, an auxiliary winding is required. They are recognizable for the hump, which is the capacitor, the starting capacitor. These kind of motors have less efficiency than 3-phase engines, usually 50 to 60%. 3-phase induction motors, on the other hand, they are used generally in industrial and professional environments, where 3-phase connections are available. Adding these extra phases make this machine very efficient and therefore appealing, reaching about 85 more or less efficiency or above. or even higher. An important characteristic is the rotation of the rotor because it spins at a lower frequency than the frequency of the stator. This concept is called slip and is measured from 0 to 1, and it could be therefore considered as a percentage of slip. It highly depends on the load of the motor. Using semiconductors for controlling the motor has greatly improved its operability. Variable frequency drives solves some drawbacks and issues that were present in this motor, such as high peak current starts, torque-speed ratio, and many more. I will leave a link in the description of this episode. Now let's move to the next type. Synchronous motor. It means, on the contrary of the typical induction motor, that the rotor spins at the speed of the frequency of the stator. These machines are used generally as generators, and they work marvelously in parallel, which is various generators interconnected working together to provide extra power, for example. Most of them have three-phase stators. This AC machine also needs DC current to work. The rotor receives DC current in order to produce the movement by interaction of the magnetic field of the stator. Synchronous machines could also work as synchronous condenser or as a synchronous capacitor for power factor compensation. If the rotor doesn't get enough DC current, it produces a lagging or positive power factor, as if it were a reactive inductive power. On the other hand, if it gets excessive DC current, then it produces the contrary effect, a leading or a negative power factor, as if it were a reactive capacitance power. They have an important downside. They don't produce a starting torque, and they lose torque if they are not synchronized with the stator anymore. One method to convert it into a self-starting machine is to add a damper winding. Next, the brushless DC motor. It shares many similarities with a synchronous. It is built with permanent magnets, which replaces the need of DC current for the rotor. The efficiency is greater than the three-phase induction motor, most of the cases, and has higher power per weight ratio. The input voltage, as the name suggests, is direct current, which works better with battery or also other DC power supplies. It requires a controller to work, which increases the price but increases the speed control maneuverability. Some models have sensors to detect the position of the rotor, especially of slower motors. On the other hand, higher speed motors, such as used in drones, are sensorless because they are able to detect zero crossing among the coils, which means, talking in English, they can detect when the positive voltage of a coil crosses to zero or vice versa. The next electric motor is the brushed DC motor. They are simple motors, and their speed and torque control is especially easy. It was achieved by the variation of voltage in the armature and field coil. Before semiconductors, applications, and tools, these motors were used whenever a speed variation was needed. They are not limited to small handheld motors. They could be also present in industries with several kilowatts of power. Their maintenance is high or frequent, since the brushes, has to be replaced periodically, among other checks. The efficiency is one of the lowest among electric motors, around 60% or so. Now comes another kind and quite different electric motor, the stepper motor. Until now, all motors in these episodes works with the same purpose: spin with force to do a certain job. It is unimportant to know the rotation position of the rotor, and they are difficult to command if it is required to spin just a revolution and a half, for example. If the application requires advancing steps, the stepper motor works better. It advances in equal steps, and it doesn't advance unless it is not commanded to do so. It doesn't need a feedback system if there is a counter registers involved. There are motors that have built to have, let's say, 50 to 200 steps per revolution. The coils receive electric pulses to move one step at a time, and it moves forward as the sequent coils advances. And finally, the servo motor. Servo or servo motors have a feedback mechanism to work. In contrast to stepper motors, they are used to determine the position of the rotors. The main purpose is not to rotate quickly in thousands of revolutions per minute as normal motors do, but to provide a quick angular movement, usually with less than 180 degrees with high torque. It requires a PWM signal to work, generally given by a microcontroller at around 50 Hz. As conclusion, there is no one motor fits all application invented yet. In every circumstance, a certain motor works better than others, since each of them has their advantages and fallbacks or drawbacks. It is therefore important to use their criteria to understand where it will perform better. And of all these motors said in this episode, which one of them have you already used? Which one is your favorite? I will leave a link in the description where you can comment in the blog Tech Zorro your favorite motor or any experience, the outstanding experience that you have had with these motors. I hope you have enjoyed this episode so far and that you have learned something useful for your next craft or project. Before you go, I just need a favor from you. Go to the application where you are hearing this right now and leave us your honest review and a like or a rating from 1 to 5 stars. This way, more people will be able to find this episode and enjoy it as well. It will mean so much. Juditova says goodbye. Until next time.
That's all for this episode. We hope that you found a moment of enlightenment and that you have enhanced your skills or cleared some doubts. For more interviews, tutorials, blueprints, and advice, go to the website techzorro.com/podcast. Juditova expects you in the next episode. Don't forget to subscribe. Happy crafting!